Okay, hey everyone. So today we're going to start talking about surface area. In case you don't know what surface area is, I found a couple of things around my house to show you. So here's just a little box. Basically, surface area is the area that's covering all of the faces. So here, here, here. Like if I wanted to paint this box or like cover it with wrapping paper, it would be like what would cover all of it. So I'm going to go over the formulas in a minute. This is a cylinder, so I just found like random things around the house, but it would be like if I wanted to cover this with paint or wrap it up, how much area is covering all of it. So I'm going to go through a few of the formulas with you. For a rectangular prism, that's like what this would be, like a box. This technically is the formula right here. You can use this. I usually just find the area of all of the faces and add them together. You'll see when I do the example. Same thing with prisms. Like if you have a triangular prism or a hexagonal prism or a trapezoidal prism like this one, it just says the sum of the areas of the faces. So you just have to pay attention to what the faces are, find the area of each one, add them all together. A right circular cylinder. So that's what this paint container is. That's a cylinder. So I just want to talk a little bit about that formula and like where it comes from. So first of all, I rewrote it a little bit better for you right here. It says 2 times the area of the base. Well, the area of the base is a circle, right? So this is pi r squared, and there's 2 of them, top and bottom. So that's where this part comes from, the 2 pi r squared. Now this part, it says circumference times height. I just wanted to show you real quick why that is. Okay, so I took some paper and I wrapped it around this part of it, right? So if I were to cut down the side of this, wrapping around like the curved part, and open it up, you get a rectangle. So that's the curved part of a cylinder. It's actually a rectangle. Like if you picture like a soup can or something, cutting the label off and laying it flat, you'd have a rectangle. Now the height, the width, I guess, is the height of the cylinder. So remember, the area of a rectangle is length times width, right? The length actually is the circumference of the circle, because watch, if I were to lay this on here and wrap it up, the length wraps up around the circle. So that's why the length of the rectangle is actually the circumference. And then the width of it is the height of the cylinder. So that's why it's the height of the cylinder times the length, which the length is the circumference. So, I mean, I usually explain that for when you have to memorize the formulas, but since obviously you're at home and you have access to your formulas for everything, you don't really need to know where it comes from, but I just thought I'd show you because it's kind of cool. A square pyramid, I pretty much, or just even not even a square pyramid, like a rectangular pyramid too, I pretty much just find the area of all the faces and add together. That's how I do it. I actually have never even seen this formula, area of the base times 1/2 times the perimeter times the slant height. I've never used that before. I usually just find the area of the faces and add. In case you're wondering, the slant height of any of these things is the slanted part. So like this slanted part would be the slant height. The actual height of the pyramid, remember from volume, would be like a straight down here. Next is a right circular cone. I rewrote it a little bit better here. This one does use the slant height. So this is the slant height. That's your L, the slanted part. Sometimes you might have to find it. Like they might give you the actual height of the cone, and then you have to find the slant height using Pythagorean theorem. And then the surface area of a sphere is 4 pi r squared. So I'm going to do a few examples, like probably like one of each one, and then you're going to practice them. So first I'm going to do this rectangular prism. So I like to label and organize my work pretty well. So like I'm going to do, say the top and the bottom are going to be the same. So I like to label top, bottom. So the top and the bottom are rectangles that are 8 by 12. So you can just do length times width, 8 times 12, and then multiply by 2. So it's going to be 2 times 8 times 12. So 8 times 12 is 96, times 2 is 192. Then how about front, back? So the front and the back are 8 by 6. So there's 2 of them, right? So 8 times 6. So that's going to be 48 times 2, which is 96. And then the left and the right. So the left and the right are 6 by 12. So you're going to do 2 times 6 times 12. So 6 times 12 is 7. 6 times 12 is 72. And then times 2 is 144. And then lastly, for the total surface area, you're just going to add them all together. So we're going to have 192 plus 96 plus 144, and we get 432, and that's square meters. Okay, so that's a rectangular prism. Like I said, I like to just find the area of all the sides and then just add them together. Okay, next, number 4. This is a triangular prism. So remember, a triangular prism is when you have like bases that are triangles and then the rest of the sides are rectangles. So this one happens to be, the triangles happen to be equilateral. So I see 9, 9, and 9. So when the triangles are equilateral, all the rectangles are the same. If the triangles were not equilateral, the rectangles would not be the same. So that'd be like something like this. These triangles are not equilateral, so like this rectangle is going to be different from the bottom rectangle, is going to be different from that rectangle. Versus this one, all the rectangles are the same. So for this, again, I like to just do like front, back, sides, add them together. So front and back are triangles here. And we know the base and we know the height, and there's 2 of them. So it's going to be 2. And then remember, the area of a triangle is 1/2 times base times height. So it's going to be 1/2 times 9 times 7.8. And that's going to be the front and the back. So 1/2 times 9 times 7.8 is 35.1. And then there's 2 of them. So it's going to be 70.2. And then the faces, so the rectangle faces, there's 3 of them. And they're all 9 by 12. Now, you just always want to make sure, like look at each one. This one's 9 by 12. This one is 9 by 12. And then this one's 9 by 12. So 3 times 9 times 12. So 9 times 12 is 108. And then times 3 of them is 324. And then you just want to add them together. 324 plus 70.2. And you get 394.2. So the surface area here is 394.2, and this is square centimeters. So that's a prism. Next is a cylinder. So I wrote the formula here. Remember, this is the area of the bases, and then that's the curved part, like the rectangle that I showed you guys. So this one's pretty easy. You just plug it in. So our radius is 2, so you're going to have 2 times pi times 2 squared plus 2 times pi times 2 times the height, which also happens to be 2. That's just a coincidence here, but that's the height here. So then I always do like this part and then this part and then add them together. So this is going to be 2 times pi times 4, which is 25.13. And then again, actually 2 times pi times 4, which is 25.13. So this doesn't always happen. That's just a coincidence. 25.13 plus 25.13 is 50.26. Don't mind my dog barking downstairs. And this is meters squared. So cylinder is pretty easy. If you were given the diameter, let's say, here's one where you were given the diameter is 12. Just remember, you have to cut that in half for the radius. Okay. Next we have a pyramid. So a square pyramid, and then we'll do a cone and a sphere. So here's a pyramid. Remember, this was the one that I said there was this formula here, but I'm not really familiar with that formula, so I don't want to use it. Okay, so we have the bottom of the pyramid is a square. And I know that because it says it's a regular pyramid, by the way. Typically, they would like mark it all. So 14 times 14, that's 196. And then since the bottom is a square, all of the triangles are going to be the same. So there's going to be 4 triangles. So it's going to be 4 times 1/2 times the base times the height of the triangle, not the height of the pyramid. So in this particular example, we're going to have to find the height of the triangle. So this would be the height of the triangle, like this slanted part. So if I draw in this, do you see how I have this right triangle here, like inside of the pyramid? So this is 12. This is going to be 7, right? Because this whole thing is 14. So I just have to do Pythagorean theorem. So off to the side, you're going to do 7 squared plus 12 squared equals x squared. And that's going to give you the height of the actual triangle faces. So let's see, 49 plus 144. And then the square root of that is going to be 13.89. So that's for the height of the triangle. So 13.89. Okay, so let's see, 1/2 times 14, the base, times 13.89, the height of the triangle. That's 97.23 for each face, and then there's 4 of them, so times 4, and you get 388.92. And you're going to add these together, which is 584.92 square feet. Okay, next is a cone. So for a cone, we have pi r squared, that's the bottom, and then the curved part is this. So this is the bottom, and then curved part. So we have the radius here is 10, so it's going to be pi times 10 squared plus pi times 10 times L, which is the slant height. So we need to find this again. So that's going to be x. So again, we're going to do Pythagorean theorem. So you're going to have 10 squared plus 25 squared equals x squared. So 25 squared is 625 plus 100 is 725. Square root of 725 is 26.93. So this is the slant height. I should have put an L here for slant height. So we have the bottom, and now 10 times the radius times the slant height, which we just found is 26.93. So again, just like the cylinder, you're going to find each part and then add them together. So 100 times pi is going to be 314.16, and then pi times 10 times 26.93 is 846.03, and then lastly you're going to add those two together. So 846.03 plus 314.16, it's going to be a final surface area of 1160.19, and then that's square feet. Okay, so that's a cone. And then lastly we're going to do a sphere. So sphere is pretty easy. It's 4 times pi times the radius squared. So first the radius here is going to be 16 because the diameter is 32 rather. So you're just going to plug it in. 4 pi times 16 squared. So remember, you want to do the squaring first. So 16 squared is 256, and then times 4 pi. So this is going to be 3,216.99, and that's square meters. So I also just wanted to come back to these composite figures. So the composite figures, the directions technically said find the surface area and volume. I had you guys just do the volume last time. So today I want to show you how you could do the surface area of them. So I am going to redraw this on the whiteboard, and then we'll find the surface. Okay, so if we're going to find the surface area of this composite figure, it's a little different than the volume, because for volume, you just find the volume of the cone, find the volume of the cylinder, add them together. For surface area, you have to remember that we only want what's on the outside. So if you could imagine, if you could imagine, like, this is kind of what it's like, right? We have a cylinder, we have a cone. The formula for the surface area of a cone is the curved part and the bottom. But if this cone is on top of this pyramid, then I don't want the bottom, right? Because I'm only painting the outside of it. I only want the outside. Same thing with the cylinder. The formula for the surface area of a cylinder takes care of like the top and the bottom. There's two bases. But if the top of the cylinder is like right up against the bottom of the cone, then I don't want the top of that. So basically what you have to do is you have to subtract the circles from each one. So here, I will show you. So for a cone, let me go back to this for a second. Remember the surface area of a cone, this represents the bottom. So I really only want this part. It's actually called the lateral surface area. Lateral surface area is the surface area without the base. So I only want this part of the cone. So for the cone without the base, whoops. Cone without the base is just pi times r times L. And then the cylinder, we only want with one base. So if you take a look at the formula for cylinder, it's 2 pi r squared, so it's 2 times area of the base. So we only want one of those. So it's going to be pi r squared, just one of them, it's just one base, plus the round part. And that one is just as is. Okay, so then you just plug in the information and then add them together. So let's do the cone. So the cone is just pi times r times L. So that's going to be pi times the radius is 5. It's kind of hard to see here. And the slant height was 13. So let's see. Pi times 5 times 13 is 204.2, well, 0.2. And then the cylinder, remember the cylinder with only one base is going to be pi times 5 squared. That's the one base. Plus 2 times pi times 5 times the height, which is 12. So pi times 25 is 78.54. And then 2 times pi times 5 times 12 is 376.99. And then we're going to add those two together. So 376.99 plus 78.54. Okay, so this is for the cylinder, this is for the cone, and then you just want to add them together. So 204.2 plus 455.53, and your final surface area is 659.73. And this is square centimeters. So that's how you would do a composite. So real quick, if you look at the rest of the ones on this paper, I'm also going to have you do these if you want on your final assessment that we're going to have, not final exam, but our last assessment. There is, I think, one of these on here on your assessment. So something like this, you're going to do like the curved part of the cylinder, the top of the cylinder. You're going to do the entire rectangular prism. However, you have to subtract this circle here on the top. So you just want the part that's on the outside. Like this one is going to be 1, 2, 3, 4, 5 rectangles for the bottom part, not the top rectangle because that's on the inside, and then 4 triangles. So you're just doing all the parts that, like if you were to paint the outside of it, anything that would be showing. All right, so I hope that's helpful. Please let me know if you have questions, or you can come to our help session. And that's it. So have a great